listen to this story. Imagine this. Almost 100 years ago, on a cold winter evening in 1929, on the slopes of Mount Wilson in sunny California, the air was so clear it felt like you could reach out and touch the stars. Inside a massive cathedral-like dome sat a man, Edwin Hubble. His eyes, tired from hours of studying nebulous galaxies, glowed with a unique intensity. Every pinpoint of light he captured through his 100-inch telescope told him a story, and this story was incredible. Everyone thought our universe was a static, motionless, eternal ocean of stars. But the numbers Hubble plotted on his graphs didn't lie. Galaxies weren't just existing, they were moving away from each other. The universe wasn't static. It was, in fact, expanding. It was like spending your whole life thinking your home was a fortress, only to suddenly realize its walls were slowly but surely drifting apart. And if it's expanding, that means at some point it must have been smaller, much, much smaller. That's how, not with a noisy explosion, but with the quiet scratch of a pencil, the idea we now call the Big Bang was born. Our cosmic birth from a single, incredibly dense point. But you know what's most amazing about science? Just when you think you've solved one great mystery, 10 new ones immediately pop up, forcing you to question everything all over again. If you're already enjoying this story and you're ready to dive into the deepest cosmic enigmas, don't forget to like this video and, of course, subscribe to our channel. That really helps us create more incredible stories like this. And while you're doing that, let me ask you a question. From what city and what time zone are you watching our lectures? Let us know in the comments. We'd love to hear from you. Now, let's return to our point. We're used to this picture. The Big Bang is the absolute beginning, the starting point of all existence. Boom! And here we are. Simple, logical, convincing. But what if I told you that this point, this great boom, wasn't the beginning of all creation, but merely a portal, an opening of a door, a funnel? Imagine you're looking at a huge puddle after the rain. See how its surface bubbles? What if each of those bubbles is an entire universe, and ours is just one of them, emerging from a giant invisible ocean whose laws we have yet to understand? What nonsense, a skeptic might exclaim, and you can understand why. You're saying our Big Bang was just a sneeze from some other gigantic universe? That's pure fantasy. Yes, it sounds crazy. It's like being born in a room, believing it's your only world, and then suddenly someone shows you a window, and beyond it is a whole field, a forest, mountains you never knew existed. Scientists have puzzled for years over what came before the Big Bang, a question that drove them mad. But what if the answer isn't before, but from? What did we emerge from? What cosmic foam? This new audacious model doesn't just push the start button further into the past. It completely changes the very concept of our birth. We didn't just appear. We perhaps transitioned. Like water seeping through cracks in a rock to become a new stream, our universe, with all its stars, galaxies, black holes, and of course us, is not an isolated phenomenon, but part of something bigger. It's like turning on the TV and there's a movie playing. You only see the movie. But what if the TV is just one of many screens in a huge cinema, showing dozens of different films simultaneously? And so, our story, the Big Bang story we knew, becomes merely a prologue. Exciting, but still a prologue to a much grander saga. Imagine, the night of September 23rd, 1846. Berlin Observatory. Johann Galle, a young astronomer, gazes intently into the eyepiece of a telescope. His hand trembles slightly. On the table is a letter from the French mathematician Urbain Le Verrier, who had predicted the location of a new, invisible planet with incredible accuracy. Why? Because the orbit of Uranus, the seventh planet from the Sun, was behaving, to put it mildly, strangely. It didn't fit Newton's elegant equations, as if someone invisible was constantly nudging it sideways. You know, it's like driving on a perfectly straight road, but your steering wheel itself kept gently pulling you into a ditch, and no one could understand why. And then, Gala sees it. Neptune. A planet that had always been there, but that no one noticed until its gravitational presence began to spoil the perfectly ordered picture of the cosmos. And by the way, if you enjoy delving into such cosmic mysteries and unraveling them with us, don't forget to like this video and subscribe to the channel. Your support helps us create even more captivating content. And one more question. From what city and what time zone are you watching our lectures? Write in the comments. We'd be very interested to know how vast our cosmic audience is. So, the story of Neptune is an excellent metaphor for our modern cosmology. We thought we understood everything. We had the Big Bang, galaxies, stars, planets, a beautiful, coherent picture. But then, cracks began to appear. Strange anomalies, inexplicable jerks that seem to say, hey, something's not right here, or something is missing. For example, let's take galaxies. We see how they rotate, how stars move in their orbits. We can measure the total mass of visible matter, stars, gas, dust. And you know what? There's not enough mass. It's like walking into a supermarket and the shopping cart you pushed moves much faster than it should, given the weight of the groceries inside. Physicists are like, what the hell? Where did the rest of the mass go? That's where dark matter comes in. An invisible ghost. Interacts with nothing but gravity. Doesn't emit light, doesn't absorb it. It cannot be seen, touched, or even simply felt. It makes up about 27% of the mass energy of our universe. 27%? That's not a little bit. That's a lion's share. Think about it. Almost 5 times more than everything we can see and measure. It's like living in a house where 85% of its walls are invisible and made of something you can't even comprehend. And then, it gets even more exciting. When scientists started measuring how fast the universe was expanding, they expected this expansion to slow down. Well, it's logical, right? Gravity should pull everything back, like a rubber band you've stretched and released. But it's accelerating. Imagine, you throw an apple upwards, and instead of falling, it suddenly starts gaining speed and flying off into space. Slowly at first, then faster and faster. This is a shock. It's like someone else was constantly adding fuel to a rocket, but you couldn't see anyone around. This is dark energy, even more mysterious. 71% of the universe, an unknown force that pushes space-time apart. It is the engine of cosmic acceleration, the reason for our increasing solitude. And that's not all. There are oddities in the cosmic microwave background radiation, the echo of the Big Bang, which should seemingly be perfectly uniform, but actually has its spots and cold points that are difficult to explain. Or anomalies in gravitational lensing, where light from distant galaxies bends in ways not predicted by visible mass. We live in a universe that, like old, beautiful furniture, has suddenly started creaking and cracking at the seams. It's just an incomplete understanding, a skeptic might say. We haven't discovered everything yet. Of course, we haven't discovered everything. But these cracks are too fundamental. They make up 95% of everything that exists in our universe. Do you understand what I mean? We see only 5% of the iceberg, and the rest is something completely different, invisible, and incomprehensible. Perhaps these inconvenient parts, dark matter, dark energy, strange gravitational anomalies, are not just bugs in our model. Maybe they're features, like moles on a body that indicate your family tree, like alien genetic code that we carry within us, without even realizing it's not our own code at all. These mysteries may not just be missing elements. They could be clues. Clues that we are not simply the product of one Big Bang, but just a tiny piece of something immeasurably larger, part of another universe. Imagine Rome, the hot summer of 1633. The Vatican Palace, grim halls where the air seems electrified with tension. Galileo Galilei himself, already an old man, stands before the Inquisition. Not for heresy in the strict sense, but for mathematics, for daring to assert Earth is not the center of the universe, but merely a speck of dust circling the sun. Whispers, condemning glances, accusations of madness, of trampling on authority. To them, his words were not just nonsense, but dangerous heresy, an attack on the entire established worldview. Yet he simply saw further. He simply dared to look at the world differently. By the way, if you are as interested in breaking old dogmas and looking beyond the horizons of knowledge as we are, then don't forget to like this video and subscribe to the channel so you don't miss new exciting discoveries. And write in the comments from what city and what time zone are you watching our lectures. We'd be very interested to know. Now let's get back to our story today. You know what's funny? History loves to repeat itself. Every truly revolutionary idea, be it Copernicus's theory, Darwin's evolution, or Einstein's relativity, always began with the same orchestra of skepticism, ridicule, and statements like, "What nonsense! That's absurd!" And only then, slowly, bit by bit, came that enthusiastic, "But it's brilliant!" So it was with the flat Earth that suddenly became round. So it was with the Sun, which turned out to be the center, not the Earth. So it was with monkeys, who suddenly became our distant relatives. And now we stand on the threshold of a new revolution. A concept is emerging that makes physicists grit their teeth, some from indignation, others from pure delight. It challenges the most sacred cow of modern cosmology, the Big Bang singularity. Imagine this. You've spent your whole life learning that our universe emerged from a tiny, infinitely dense point, as if the entire cosmos was compressed into a volume smaller than an atom. And this, seemingly, explains everything. But what if that point never existed at all? "What nonsense!" some will immediately exclaim. "How can you even propose such a thing? The Big Bang is our foundation. It's the basis upon which all modern cosmology stands. If you remove the singularity, everything will crumble like a house of cards." And they would be right, up to a certain point, because that's the beauty of science. Even the strongest foundations sometimes need to be tested for strength. Some physicists, seeing anomalies and inconvenient facts, remember we talked about them in the last section, began to ask this childish question. What if our picture of the world is incomplete? What if we are looking at the great book of Genesis, but only seeing one, albeit very bright, page? This new, audacious hypothesis. It's like that child who suddenly declares in the middle of a formal dinner, "But the emperor has no clothes." All the adults are shocked, indignant, shushing, but he looks with such clear eyes and says, "Well, it's true, isn't it?" At first, it seemed like heresy, pure speculation that broke a seemingly perfect model. But the more scientists looked into this nonsense, the more they found in it elegance, beauty, and most importantly, potential solutions to those very cracks in the universe we spoke of earlier. It was like trying to put together a puzzle, and 2 or 3 pieces didn't fit. You could decide the puzzle was flawed, or you could think, what if these pieces are just from another puzzle, which is actually part of a huge picture? And this idea, initially met with only condescending smiles or outright irritation, began to gain traction. It proposed not just fixing the Big Bang, but rethinking its very essence. It invited us to look behind the curtain, beyond the beginning we had come to consider absolute. It opened the door to a completely new, astonishing scenario for our birth. Ready to find out what it is? August 27th, 1883. Above the Sunda Strait between Java and Sumatra, the heavens ripped open. No, that's not a figure of speech. Down below, the Krakatoa volcano put on such a fireworks display that the sound of the explosion traveled almost around the entire planet, and ash rose for tens of kilometers, obscuring the sun. Imagine, yesterday there was something, and the next morning, infernal power spewed from the depths of the earth. An entire island was literally torn to shreds, and in its place remained only memories and a new, altered topography of the ocean floor. This was not just an eruption, it was the birth of a new reality, brutal, sudden, and changing everything forever. By the way, if you, like me, enjoy exploring the mysteries of the universe and solving the riddles of existence, don't forget to like this video and subscribe to the channel. Your support helps us create even more captivating content. And please tell us, from what city and what time zone are you watching our lectures? Write in the comments, we'd love to know. Now let's return to our cosmic birth. Listen, what if the birth of our universe was something similar to Krakatoa, only on a much grander scale? We're used to the idea of the Big Bang, where everything began with a mysterious, incomprehensibly dense point. A singularity, kind of like poof, and it's done. But imagine, scientists looking at this singularity sometimes scratch their heads. How could it be? What was before this point? Where did it come from? Wait, I hear the skeptics say, you're saying there was no point? But then how did everything begin? And that's where a new, devilishly elegant, yet shocking model comes into play. It says, what if our universe isn't some isolated click of emptiness, but rather a bubble? Yes, an ordinary air bubble, which suddenly emerged from a giant bubbling ocean. Imagine a pot of boiling water. It bubbles and froths, and each such bubble, rising to the surface, pops. Now multiply that by infinity, and imagine that the water is the very parent universe, and each bubble is potentially our universe. This means that our universe didn't explode out of nowhere. It emerged from something already existing. Like soap in water, which suddenly forms a perfect sphere, and then disperses into millions of microscopic splashes. And this emerging bubble began to inflate, like a balloon filled with air. And its shell, that's what we now call our universe. What does this give us? Well, first of all, it allows us to bypass the problem of that initial singularity, which many physicists found so, well, not entirely convenient. It's not that they didn't like it. It just didn't provide answers, but rather posed new, even more complex questions. Hold on, the skeptic interjects again. You're saying we're literally foam? In a sense, yes. but not in a derogatory way, rather a stunningly massive one. This idea radically changes our understanding of the beginning of time. Instead of a sudden beginning out of nothing, we get a continuation. Our universe becomes not a unique one-time event, but just one of countless birth acts in a much older and vaster structure, like a dewdrop on a huge lotus leaf. The drop seems self-sufficient, but it is part of a much larger whole. This model paints a much more dramatic and cinematic scene. Instead of an explosion, a spectacular appearance. Instead of chaos, an astonishing structure that was already inherent in the parent universe. You see, this isn't just changing numbers in a formula, it's a paradigm shift. We don't just inhabit an expanding sphere. We live on one of the facets of a bubble blown in a gigantic, unimaginable cosmic progenitor. And that, you'll agree, sounds much more interesting than just bang. The year, 1869. Dimitrovka, a small Russian village buried in snow. Meanwhile, in the warm study of St. Petersburg University, Professor Dmitry Mendeleev lays out cards on a table. On each card, the name of a chemical element and its properties. He's playing a cosmic solitaire, trying to find a pattern that had eluded everyone. And suddenly, a click. He didn't just see order, he predicted the existence of yet undiscovered elements, as if guessing future children by the features of their unknown parents. He looked into the very genealogical tree of matter, into a world invisible to the naked eye. Just as, you know, we are now trying to see that parent universe that might have given life to ours. Before we continue this exciting journey to the origins of the universe, a small but very important point. If you like what we do, if these cosmic stories resonate with your soul, please subscribe to the channel and like this video. It helps us grow and create even more interesting content. And by the way, we're very interested. From what city and what time zone are you watching our lectures? Write in the comments, we'd love to know. Now let's return to our cosmic parents. Imagine this. If our universe is like a newborn, curious bubble in a giant bathtub, then what kind of bathtub is it? What could this parent universe have been like? This isn't just an exercise in imagination. Physicists, these tireless detectives of the cosmos, are already trying to paint its portrait. And it, I tell you, bears little resemblance to what we're used to. Firstly, this parent universe could have been much, much larger. Ours might be just a tiny speck in its boundless expanses, like one of billions of grains of sand on a giant beach. And the laws of physics? This is where it gets really interesting. Perhaps gravity there doesn't attract, but repels. Or maybe it operates on completely different principles that we can't even imagine. And time? For us, it flows only forward, a one-way ticket. But what if it's cyclical there, or even moves backward? Imagine a world where a broken cup immediately reassembles itself, and instead of aging, you get younger with every second. Oh, come on, that's pure fantasy, some skeptic might exclaim, and I perfectly understand them. But listen, what if in that universe, there are not 3 spatial dimensions, like ours, but 5, 7, or even 10? Our universe, in such a case, would be just a thin slice, a surface within a more voluminous space, like a 2-dimensional drawing living on a sheet of 3-dimensional paper. Remember the bubble metaphor. Our universe is like a soap bubble. It lives and inflates in the air, but the air around it is already a different, more extensive environment. And what about fundamental constants? The speed of light, the mass of an electron, the force of gravity? These numbers seem immutable to us, like the genetic code of a species. But if our universe is the child of another, then these constants could simply be one of the possible sets of parameters chosen at its birth. In the parent universe, they could be completely different. It's like two different cars having different engine settings. One goes fast, the other slow, but both operate on the same basic principles of mechanics. Or an even bolder thought, what if the parent universe is dominated not by ordinary matter, but by what we now call dark energy, or dark matter? For us, it's a mystery that makes up 95% of everything. But for them, it could simply be the air they breathe, their normal state of being. These are not just hypotheses for the sake of hypotheses. This is an attempt to understand why our universe is the way it is, why it is tuned precisely so that stars, galaxies, and ultimately we could appear in it. If we are part of another universe, then these parental traits could explain many of the strange things about our cosmic home. We are not just looking for a source, we are looking for our true cosmic lineage. Imagine a hot June in 1964. American scientists Arno Penzias and Robert Wilson are working on their gigantic horn antenna in Holmdel, New Jersey. Their task? To pick up the faintest, most imperceptible signal to improve communication. But something was wrong. From every direction they aimed their dish, there was a uniform, irritating hissing noise. You know, it was like trying to tune your radio to your favorite station, but instead of music, all that came out of the speakers was static, a monotonous hiss. They checked everything, cleaned the antenna of pigeon droppings. Seriously, that was one of their first theories. Checked wiring, electronics, even tried to figure out if it was coming from New York. Nothing. The source was ubiquitous. And it turned out they had literally stumbled upon the most grandiose echo from the past imaginable. The cosmic microwave background radiation, the great afterglow of the Big Bang, with a temperature of 2.7 Kelvin. And while we're trying to unravel these cosmic mysteries, don't forget to like this video and subscribe to the channel if you enjoy what we're talking about. It's very important to us. And you know, I'm curious. From what city and what time zone are you watching our lectures? Write in the comments. We'd love to hear the geography of our listeners. Now let's return to our cosmic detective story. Because that very relic radiation, this fingerprint of the young universe, is actually much more interesting than it seems at first glance. It's not absolutely uniform. It has anomalies. Imagine a perfectly smooth lake surface. Now throw a stone into it. Ripples will appear. The relic radiation is like such a perfectly smooth lake, across which waves of temperature fluctuations spread. And these waves, their distribution, their character, should follow certain rules predicted by the standard Big Bang model. But, as in any good detective story, there's something strange in our lake. A cold spot, alignment anomalies, asymmetry. Listen, scientists have been looking at this data for decades and saying, well, it's just a statistical fluctuation, a coincidence. Skeptics would sneer, another fabrication to get a grant. But if you look closer, these anomalies begin to form a pattern, as if someone left you a note from the past, or from another dimension. For example, there's the so-called cold spot. This is a huge region in the relic radiation that is anomalously colder than it should be according to standard models. Yes, of course, statistically it's possible, but it's too big. It's like if your perfectly baked pizza suddenly had a huge, perfectly round, cold area, even though the rest of the pizza is hot and uniform. Possible? Yes. But it looks suspicious. Don't you agree? Another mystery is the axis of evil. Don't be scared. It's not from a horror movie, but from cosmology. Scientists have discovered that some large features of the relic radiation, including the cold spot, seem to be aligned in a certain direction in space. Imagine you're rolling dice, and they always land on the same side and always in the same direction. Too many coincidences, isn't it? The standard model says the universe is isotropic, meaning it's the same in all directions. But here we have this alignment, as if our universe has some kind of preferred vector. And this is where the boldest ideas come to the rescue. What if these cracks in the perfect picture are not bugs in our universe, but on the contrary, direct evidence of its connection to something larger? What if these are not just statistical fluctuations, but an echo of a collision, a footprint of that parent universe from which we emerged, like the impact mark of a huge meteorite falling into the ocean, creating waves that spread for thousands of kilometers? These anomalies could be such waves left behind after a cosmic birth. Imagine you're looking at an old photo taken with a primitive camera. There's interference, noise, but among this noise, you suddenly notice the outlines of something that definitely shouldn't have been in the frame. Someone's shadow, part of another background, peeking from beyond the edge. These are our cosmic fingerprints. Not only the relic radiation gives us clues, there are also large-scale structures of the universe. Galaxies, galaxy clusters, filaments, voids. They are not distributed exactly as predicted by the simplest models. There are hints of some strange orderliness, or conversely, a lack of chaos where it should be. As if you poured out a bag of sand, and the grains suddenly lay not randomly, but formed an intricate but not entirely clear pattern on the floor, as if some invisible force arranged them there. Listen, this is not just an exercise in imagination. Scientists like Roger Penrose have been searching for and finding these oddities for decades. They say, we see traces of a previous universe. These are ripples on the water after a previous cycle. They call these traces Hawking rings. You see, these aren't just discussions about what if. This is an attempt to find physical, measurable evidence that our picture of the cosmos is just a piece of a much grander puzzle. That we are not a singular experiment, but just one of many children in a gigantic cosmic family. And these anomalies are our family album, full of mysteries and hints of our true origin. February 15th, 1543. The city of Frombork, Poland. Somewhere in one of the towers, a man named Nicholas Copernicus is preparing to publish a work that will overturn the world. Literally. He doesn't yet know that his ideas will explode not only science, but also philosophy, forcing millions of people for the first time to see themselves not as the center of everything, but as a grain of sand revolving around a much greater celestial body. And you know what's most amazing? Today, almost 500 years later, we stand on the threshold of a new, even more grandiose shift. Only now, it's not the Earth around the Sun, but our entire universe around something immeasurably larger. And if you're already curious how this could be, and you want to be among the first to learn about such revolutions in science, then be sure to subscribe to the channel and like the video. It helps us tell these stories for you. And I'm also very curious. From what city and what time zone are you watching our lectures? Write in the comments, we'd love to know. And now, let's return to our cosmic family tree. Imagine this. Your whole life, you considered yourself an orphan, the sole inhabitant of your cozy, but somewhat lonely home. And then suddenly, bam. You're told that you're not just not an orphan, but part of a huge ancient family whose history extends beyond your understanding. This is roughly the shock you feel when you begin to realize our universe may not be the only child of its kind. We are not alone. And this isn't about little green men on Mars, though we'll talk about them another time. This is about our essence. Listen, if we are a bubble in the foam of creation, if our universe emerged from another, older and grander one, then how does that change everything? Everything we knew about our beginning, about our uniqueness, about our place. So what? Someone might skeptically ask. What difference does it make where we came from? How does it affect my morning coffee or my work deadlines? Excellent question, and the answer is deeply personal and at the same time universal. Firstly, it pulls the rug out from under our cosmic ego. We loved being the only ones. The only universe, the only Big Bang, the pinnacle of creation. And then you're told, sorry dear, you're just one of billions of potential children in a vast cosmic womb. It's like finding out your village pond is just a puddle connected to a gigantic ocean full of unknown creatures and continents. Suddenly, your small reality becomes part of something incomparably larger. Secondly, it expands the boundaries of our thinking to unimaginable scales. If there's a parent universe, what are its laws of physics like? What if time flows in a different direction there, or gravity works completely differently? This isn't just science fiction, it's the real horizon of knowledge. It's like discovering that beyond your small country, there's an entire planet with thousands of other cultures, languages, and laws. Your life, your possibilities, your knowledge suddenly multiply to infinity. And what about the meaning of life and death? If our universe is a temporary phenomenon, a kind of cycle, does that mean that we and our entire reality are just part of a continuous cosmic process? This, of course, can cause a small existential crisis. But you know what? In a good way. Because this crisis opens the door to finding new meanings, to understanding our connection to all existence on a level we couldn't even imagine. We are not just inhabitants of Earth, not just citizens of the Milky Way galaxy. We are descendants of another universe. We are part of a cosmic family whose roots extend into the unknown. It changes everything. Your life, your existence become part not just of history, but of prehistory. You are a link in a chain of events that began even before the light ignited in our own universe. This makes us not less, but more. It gives us a new dimension of identity, a new depth of origin. And that, you'll agree, is much more interesting than simply being a random burst of energy in empty space. We are a concentrated energy whose lineage goes back to infinity. Feel it. It's astounding. And this is just the beginning. Imagine a cold January evening, the 6th of 1912, in Marburg, Germany. In a small auditorium before respected geologists stands a short man, a meteorologist by profession, Alfred Wegener. He isn't just presenting a weather report. He's challenging their entire worldview, declaring that continents, these immovable blocks of land beneath their feet, are actually drifting, moving across the planet like giant icebergs in a slow ocean. The geologists exchange glances, their faces a mixture of bewilderment and slight amusement. "What nonsense," they whisper. "Isn't it obvious that the Earth is solid and static?" He's a meteorologist. What does he know about geology? For decades, this idea would be considered an eccentricity, almost scientific heresy. While you're processing how entire continents can float, I want to remind you, if you're enjoying our cosmic journey and these incredible ideas make your brain creak with delight, be sure to like and subscribe to the channel. It really helps us bring science to as many people as possible. And by the way, from what city and what time zone are you watching our lectures? Write in the comments, we'd be interested. Now let's return to our battle. Because Wegener's story is just one of thousands of examples of how science truly moves forward, through debate, denial, and fierce arguments. You know, when a truly revolutionary idea emerges, it's rarely met with applause. More often, with shouts of, "What nonsense!" Physicists aren't just smart people, they're also incredibly skeptical, and that's their job. Imagine you arrive at a strong, well-built, proven house, our current Big Bang model, built 70 biburos years ago, and you say to the architect, "Listen, what if the foundation of this house is actually the roof of another much older and larger building?" The architect would probably respond, "Show me the blueprints, show me the calculations." Where's the evidence that this isn't just your wild imagination? This is exactly what's happening now, with the hypothesis that our universe could have emerged from another. This isn't a school debate where you can just beautifully articulate an idea. This is a battle of titans, where every new argument is weighed on the most precise scales. It's just speculation, some cry, demanding measurable predictions. Show us the proof. Others echo, expecting the new theory to explain all the cracks in our universe better than the old one. Because the task of science is not just to fantasize about something beautiful, but to propose a better model that explains more and predicts more accurately. And in this duel between old and new, truth is born. Every revolutionary theory, from Copernicus's heliocentrism to quantum mechanics, has gone through the same hellfire of criticism. And that's normal. Moreover, it's vitally important. Without this cross-examination, scientific progress would simply stop. Listen, when a scientist puts forward an idea that overturns everything we knew, they don't expect approval. They expect challenges. They expect every conclusion to be examined under a microscope, that every mathematical step will be recalculated, that every consequence will be called into question. Because only in this crucible of arguments and evidence is the chaff sifted out and true knowledge forged. So, when you hear about heated debates in the world of physics regarding the new Big Bang model, don't think it's a sign of weakness. On the contrary, it's a sign that the idea is strong and important enough to warrant such close attention. This is the very battle that moves us toward the next great discovery, toward understanding where we truly came from. And Wegener, by the way, was vindicated decades later when new technologies proved him right. Perhaps our new model awaits its triumph too. Remember that April evening in Axenu, 1981? No, of course you don't. But imagine, in the giant tunnels of the European Organization for Nuclear Research, under Geneva, scientists were preparing an experiment that was supposed to catch the invisible. No one was looking for another universe then, but they were going to prove that you could find particles that live for only tiny fractions of a second, like ghosts running through matter. It was an epical moment when we learned to catch what could not be touched, seen, or even directly detected. Only indirect traces, only the finest fingerprints. By the way, if you enjoy this cosmic adventure and are ready to rewrite physics textbooks with us, don't forget to like and subscribe to the channel. It helps us share such incredible stories. and write in the comments. From what city and what time zone are you watching our lectures? We are very interested to know how widespread our audience is. Well, now let's return to our ghosts from another dimension. You know, it's like losing your keys in a dark room. You can't see them, but you can step on them, or hear a jingle, or feel the cold metal. Similarly, if our universe is such a bubble or child of another, older and vaster universe, then it simply must have left behind some breadcrumbs, some faint traces of its birth. Skeptics might, of course, smirk. Well, how are you going to find that? Poke it with a stick? That's pure fantasy. And they would be partly right. But science is good because it turns fantasy into methodical search. So, how do we catch ghosts from another dimension? Firstly, it's new generation cosmic telescopes. You know, the deeper we look into space, the further back in time we look. The James Webb Telescope is, in essence, our time machine. It sees light that has traveled for 13 billion years, almost from the very beginning of our universe. And if our universe was born not in pure emptiness, but from something else, then its very first moments might contain information about the parent universe. Some anomalies in the cosmic microwave background radiation, oddities in the distribution of galaxies, slightly altered laws of physics at the very, very dawn of time. It's like looking for the finest seams on an ancient tapestry that show it was part of something larger. Secondly, it's gravitational waves. Remember how scientists first detected gravitational waves from merging black holes? It was like hearing a distant rumble of thunder from a colossal cosmic event. Now imagine, the very birth of our universe, its separation from the parent, is an event of truly titanic scale. If this theory is correct, then in the earliest gravitational waves, which may still be wandering through space, the characteristics of that other universe could be encoded. This is our cosmic fishing net for the most elusive oscillations of space-time. Scientists are already developing new, even more sensitive gravitational wave detectors capable of catching the echo of the first moments of existence. Thirdly, it's giant particle accelerators. The Large Hadron Collider at CERN is our chance to look into the tiniest scales of matter and energy. If we are children of another universe, then perhaps our own contains particles or interactions that are relics of that parent universe. For example, extra dimensions predicted by some theories could leave microscopic, almost invisible traces in our experiments. It's like trying to understand by smell what your grandmother cooked 20 years ago. Difficult, but not impossible. Physicists joke that they are trying to catch ghosts, but jokes aside, that's often how great discoveries are made. And finally, mathematical modeling. These are our cosmic detectives. We can create computer simulations that test what a universe born from another might look like. What scars might it bear? What anomalies? Then we compare these predictions with what we see in the real cosmos. If a simulation suddenly starts matching observations, that would be a powerful indirect argument. Because you see, this isn't just a beautiful theory. It's an active field of research. Scientists are already searching for these fingerprints, these breadcrumbs, that could confirm that our home is just a small room in a huge, incredibly ancient castle of creation. And who knows what we'll discover tomorrow? Perhaps tomorrow we'll catch the first ghost from that parent universe. Imagine Bern. 1905. In a small, inconspicuous patent office sits a young man, Albert Einstein, quietly writing something. The world around him lived by rules set by Isaac Newton. Absolute time, absolute space, a predictable universe clockwork. All scientists thought, this is it, the truth. We've understood everything. But this guy, who was only 26, was about to release several papers that would explode all our understanding of reality. He showed time and space are not constants. They are relative. Our picture of the world, so clear and unshakable, turned out to be just a piece of a huge, multi-dimensional puzzle. People, of course, initially scoffed. What nonsense! My clock ticks the same everywhere. And while you digest this cosmic upheaval, please don't forget to subscribe to our channel and like it if you enjoy what we're talking about here. It helps us a lot. And you know, we're always interested in where people are watching us from. Write in the comments from what city and what time zone you are listening to this story right now. And meanwhile, we'll return to our own modern-day Einstein. Because right now, listen carefully. We stand on the threshold of a revolution just as grand, perhaps even grander. You're probably used to the idea that the Big Bang is the beginning of everything, the starting point, the cosmic kickoff. But what if all of that is just part of a prologue? Our Big Bang. It might not have been the explosion of everything, but simply a click, the turning of the flywheel of a much larger, incomprehensible machine. Imagine you've lived your whole life in one room of a gigantic castle. You've studied it inside and out. You know every speck of dust, every brick. And then, suddenly, one of the walls begins to crack, and you see beyond it other rooms. Entire wings, towers, underground labyrinths. This is the feeling that's currently in the air among theoretical physicists. Our universe, with all its galaxies, black holes, and billions of stars, might be just one of countless bubbles in the boiling ocean of a much larger multiverse, or like a leaf on a huge cosmic tree. Wait, you might say. These are just metaphors. How does this even change my life? My breakfast still gets cold, and I still run late for work. And you'd be right. On the surface, nothing changes, but deep inside. Remember how the world changed when we understood that Earth wasn't the center of the universe. Not immediately, but gradually. This reconfigures our self-awareness, our place in the universe. You see, this isn't just another scientific discovery. This is a rewriting of the very foundations of our existence. If we are children of another universe, then who are we? Where are our roots? Our entire cosmic history, written in textbooks, in popular science books, in lectures. It's like a single frame from a multi-hour epic film. And we are only now beginning to see the other reels of film. It's like when you discover that your old family photograph is actually just a small fragment of a huge canvas depicting an entire generation of your ancestors whom you never even knew about. Everything changes. Perceptions of time, of space, of the birth and death of universes. We stand on the threshold of something truly incredible. This is not just a hypothesis. It's a daring challenge to everything we know. It's an invitation to look beyond the horizon of the known and realize that the cosmos, it's far stranger and more amazing than we could have ever imagined. And you know what? You were here. You heard it first. You witnessed how the story of everything, the story of our everything, is preparing to be rewritten. Are you ready for it? Because it's only going to get more interesting.